Could a black hole be a tunnel to another universe? Because in sci-fi, a black hole is a door. But in real physics, gateway has two meanings. One, a gateway in the math, a space-time geometry called a wormhole. Two, a gateway you can travel through, the part Hollywood never price tags. Today, we're drawing a clean map, what Einstein's equations allow, what nature likely builds, and what any telescope could ever confirm. First, a black hole isn't a thing you fall into like a cave. It's a region where gravity warps space-time so extremely that there's an event horizon, a boundary where outward paths stop leading outward. Fact: in classical general relativity, once you're inside the event horizon, you can't send a signal back to the outside universe. This is why black holes feel like doors, but it's also why they're terrible doors. Here's where the wormhole story begins. In the equations for a simple, non-spinning black hole, the Schwarzschild solution, there's a mathematically extended version of the spacetime. Fact: that maximally extended solution contains two outside universes connected by a bridge, an Einstein-Rosen bridge. So yes, wormholes appear in real physics. But watch what happens next. The classic Einstein-Rosen bridge is a trapdoor that snaps shut. Fact: in the original classical setup, the throat closes too quickly for anything, light included, to pass through from one side to the other. So if you've heard, a black hole contains a wormhole, the precise translation is a wormhole exists as a feature of an idealized solution, but it's not a usable shortcut. And there's another reality check. Inference. Real astrophysical black holes form by collapse. The neat, eternal, perfectly symmetric two-universe picture is not a faithful description of how actual black holes are born. Okay, so the famous bridge is non-traversable. But can the equations produce a wormhole you can cross? Fact: yes. There are traversable wormhole geometries, famously studied by Morris and Thorne, where a throat stays open long enough for travel. But the geometry demands support, like holding open a tunnel in a mountain, and the support isn't normal matter. The key phrase is exotic stress energy. Fact: in the simplest traversable wormhole models, the matter supporting the throat violates a common energy condition, often the null energy condition. In plain language, it behaves like it has negative energy density from certain viewpoints. Now, negative energy sounds like a cheat code, but physics doesn't hand out cheat codes. Fact: quantum field theory allows negative energy densities in limited settings, like the Casimir effect. Guardrail. The Casimir effect does not mean we can bottle negative energy to build a portal. The amounts are tiny, and there are strong theoretical constraints, often discussed as quantum inequalities, limiting how much negative energy you can have, and for how long. Inference. Even if nature permits traversable wormholes, keeping one open at macroscopic scale looks extraordinarily difficult. So what about the boldest claim? Black holes as gateways to other universes. Here's the clean line. Fact: classical GR predicts horizons and a breakdown at singularities, places where we expect quantum gravity to matter. Speculation. Some ideas propose black holes could connect to baby universes, or that the interior could bounce instead of ending. But these require unknown quantum gravity physics. None of this is established. None of it is observed. And we should avoid the lazy sentence: we don't know what happens inside, so anything could happen. Guardrail. Uncertainty is not permission to claim portals. Then there's the idea that sounds like science fiction, but lives in real papers. ER EPR. Fact: ER EPR is a conjecture suggesting a deep relationship between entanglement, EPR, and wormhole-like connections, ER, in certain theoretical contexts. The important translation: speculation. Careful. It hints that space-time geometry and quantum information might be linked in a way we don't fully understand. Guardrail. ER EPR does not mean astrophysical black holes are traversable portals. It does not grant you a tunnel you can steer a spaceship through. It's more like the universe might be stitching itself together with entanglement. Let's say wormholes exist. Could we recognize one? Inference. Maybe. Indirectly. People propose signatures like unusual gravitational lensing patterns, accretion behavior that deviates subtly from a black hole, or echoes anomalies in time-domain signals. But here's the trap. Fact. Many proposed wormhole signatures can be mimicked by other compact objects or by uncertainties in messy astrophysical environments. So detection claims demand extreme caution. We're not guessing in the dark. Fact. The Event Horizon Telescope has imaged black hole shadows like M87 Theta and Sagittarius Aj, and those images are broadly consistent with GR black holes. Fact. LIGO and Virgo have detected gravitational waves from merging compact objects, including black holes, matching the black hole merger story GR predicts remarkably well. None of this proves wormholes cannot exist, but it does mean if real wormholes are out there, nature is at least very good at making things that look exactly like ordinary black holes. So, can black holes be gateways? If you mean a doorway you can use, the answer is not by anything we currently understand. If you mean a gateway in the equations, then yes, wormholes exist as solutions. But physics is not just what can be written. It's what can be formed, stabilized, and tested. And here's the twist. Even if black holes aren't portals, they're still gateways. Gateways to the edge of what we know, where gravity, quantum mechanics, and information collide. So the honest wonder isn't, where does the tunnel go? It's, what does the universe become when space-time itself is pushed to the limit? Decision tree recap, crisp, no hype. Final recap, use this like a decision tree. 1. Are black holes real astrophysical objects? Yes, fact. Eat images. Gravitational waves support GR black holes. 2. Does GR allow wormholes in the math? Yes, fact. ER bridges and other wormhole solutions exist. 3. Is the classic Einstein-Rosen bridge inside a Schwarzschild black hole a usable passage? No, fact. It's non-traversable. The throat pinches off. 4. Do traversable wormholes exist in theory? Yes, fact, if supported by exotic stress energy. 5. Do we know nature can stabilize the needed negative energy at macroscopic scale? No, fact inference. Negative energy exists in QFT in limited ways, Casimir, but constraints make engineering a traversable wormhole highly doubtful. 6. Do black holes lead to other universes? Unknown, speculation. Baby universes, bounces, quantum gravity ideas. No observational confirmation. 7. Is ER EPR proof that wormholes are real portals? No, fact. It's a conjecture about deep structure, not a travel mechanism. That's the map. Wonder with guardrails.